All right, so welcome to the Clay 3D printing class. Again, this is the first iteration of this class, so thank you for being guinea pigs. I just wanted to start just introduction-wise about like what 3D printing is for those. Neither of you have done any kind of 3D printing? Okay. So I'll go through a quick overview, and then today what I want to really do is dive into one of the softwares that we have, just so that we can start constructing models outside. You can go home, you can play with the software, put some models together. That way next week when we learn how to use the machines themselves, you'll have something that is ready to go. So that'll give you time. If you have questions, feel free to ask me throughout the week. My name and number and email are on the board. I think I also included it in the introduction email. And if you have any questions along the way, feel free to ask me. I'm happy. Don't feel like you're interrupting me or anything. I'm happy to stop. So the first part I wanted to talk through is just how do we get to what the printer does. So there are three kind of big steps to making a 3D print. The first step is modeling. So this is where we use some kind of software to construct a 3D model. So we're creating points and edges and faces and bodies in, a software representation of 3D. There's a couple different pieces of software that you probably have at least heard of, at least in passing. The one that we're going to be, there's two that we're going to be exploring in this class. That's Fusion, which is they call it a parametric modeler. So it is really about defining two-dimensional shapes and then using transformations to make those two-dimensional shapes into three-dimensional shapes. There's Blender. That's a more sculptural program, so that represents 3D objects as their actual points in space, and then you can manipulate those to make objects. There's also software like Rhino. Rhino's pretty similar to Fusion. It's a parametric modeler. It has its own kind of tweaks on things, but they're pretty similar concepts. If you learn Fusion, you'll be able to use Rhino and vice versa. That's true for some other 3D modeling softwares as well. For example, ZBrush is another kind of sculptural modeler that's very similar to Blender, as well as Maya is another sculptural modeler. And these really come from two separate worlds that have been starting to converge as this technology grows. So programs like Fusion, like Rhino, like SolidWorks, those all come out of the machining world. These were all softwares that were created to take the idea of drafting and then make it computerized. So this is the realm of Autodesk and AutoCAD and all of that kind of stuff. So the intention of these softwares is to be very precise. They let you define exact measurements of things, diameters of things, offsets of things, as well as constraints around those. Like this circle must be parallel to this line, or this line must be perpendicular to this other line. Those are things that we can define while we're making our models. On the flip side of that, programs like Blender and ZBrush and Maya, these came out of the 3D animation world. So these were people that were making movies or video games and things like that that didn't necessarily need the exacting constraints of like I'm making a part for a machine. Rather they needed the I need this to look representational to what I am trying to do with this animation. So you get a lot more tools about I want to smooth this into that, or I want this to be an organic representation of this straight line that I've made.
Can you add two objects that you created in Fusion? Let's say you made an ellipsoid, right? 3D ellipsoid, and you want to place a nose. Right?
Absolutely. Yeah, and we can do that. And in fact, we can try that when we get a little bit further along about, if we had two separate models, how would we put those together? It's actually not that hard to do that. And in addition to Blender, there's another piece of software that we can explore if that's something that you're looking at doing a lot of, called Mesh Mixer. Its name kind of explains itself. It takes multiple 3D meshes and lets you put them together easily. So that's kind of the first step, is using these pieces of software to create a 3D representation of something in the first place. There's a lot of different files that these programs will tend to output, but there's some standard ones. The ones that we'll probably be working with in this class are STL files and 3MF files. So when you see these files coming out of the software that we're using, those are kind of the saved versions of the models that we're making in a universal format. So for example, STL files, any of these programs that you create an STL file with, another one of these programs would be able to open. That's why we're choosing those. Some of them, especially Autodesk, has a lot of its own file formats. We're going to avoid those just because then you can only use Autodesk, and I don't want to lock anybody into anything. 3MF is a more modern version of STL that more companies are starting to pick up on. I don't know if Blender uses 3MF yet, but Fusion certainly does, and going from step 1 to step 2 with 3MF is a little bit less complicated, so we'll tend to prefer that, but I'll talk about them interchangeably. So if you hear me say, we'll look for the STL, I might actually mean 3MF, so don't get confused on that. So after step 1, what we have is a bunch of points and faces and edges in space that are represented by a file. But that's not enough to describe to the printer what we actually want to do. So the next step of what we do for 3D printing is we actually use another piece of software called a slicer. And that's pretty descriptive of what this software actually does. So what slicing does is it takes your 3D model and it looks at it layer by layer to see how does the model represented in a two-dimensional slice as you go up in usually the Z direction, so up and down, in order to know what to tell the 3D printer how to move. So you can see, like, you take our cube that we originally modeled with points and edges. When we put it into the slicer, it's going to take a look at some section of that and then try to figure out how do I move the 3D printer in order to get it to be that slice of the model. So, for example, it could make this slice of the cube by first going around the outside and then zigzagging across the middle to fill in that space. So there's a lot of settings that you can do inside the slicer to change its behavior in this, right? So I could model a cube, but maybe I actually want it to be a vase, and it's in the slicer that I can tell it, just print the edges of this thing, don't worry about printing the middle. So for example, almost all of these models like this were modeled as a solid, and then to make it into a vase, I actually changed that in the slicer. So
you got to know both, so you know what you can handle, what you can punt to the next.
Exactly,
so
yes.
When you do it in Fusion or Plus in Blender, you kind of model the outer shelf of it, so to speak. The form that kind of external form.
I would be more specific in the way that I say it. So yes, you definitely model the external form. If you want the internal form to be something specific, you would also model that. So for example, if you look at this vase, right, the inside of this vase follows exactly what the outside is doing. And that's because in the model, this was a solid, and in the slicer, I just told it, don't worry about the inside. So it's just going to say, okay, well, I'll just make one spiral around the outside to build this. But if I wanted the inside of this to be a different shape, maybe I wanted it to be like a concave U shape, I would want to model that too, because there's no way the slicer could know that I'd want it to look different. So the way that I would say that is you need to model the things that you care about in the print. So I don't care about the inside of this vase, I can control that in the slicer. Or if I wanted this to be a specific thickness, I might want to model that in the slicer, or in the modeler rather than the slicer. There are controls for that in the slicer, but it's never going to be as precise as what you can do in the modeling.
Can I ask one more question?
Absolutely, you can ask as many questions as you want.
In your example with the cube, you want just completely solid slice, you don't want any opening. So then how you fill it, there are different ways to fill it, and I understand.
Yep.
But the time of these different things.
It makes a huge difference.
Huge difference.
Yes,
So
and material.
It's like you can
yes.
go like this way. If you go around, potentially, the time and material.
Exactly. So, and there'll be a lot of settings for that in the slicer, and we can talk about that next week when we're at that step. So for example, this took about an hour and a half to print. It's completely hollow. and we cheated because the bottom of this, we printed onto an already existing clay slab. So that's a good way to save material. If I printed this solid, it would have probably taken all day because now the extruder needs to travel back and forth for each one of these layers. And there are mediums in between, right? So this form, no, this form's hollow, but there's this form is a good example. You can't see in it, but it actually has, in order to support these curves, it has ribs inside of here, and you can define how solid you want something to be in the slicer. And so we'll talk about that because there are certain shapes that we can't print just due to the nature of printing slice by slice. And so we'll talk more about that next week when we're talking about the slicer. But don't be surprised if you go home, make some models, come back next week, and I tell you, this looks amazing, but we can't print it. So that's the role of the slicer, and what it is outputting is what ends up being a giant text file of all of the commands that the 3D printer needs to follow in order to make these slices come out correctly. It's more human readable than an STL. If you open up these G-code files, that's what it usually produces, you'll see a bunch of commands. It'll be like move from x90, y30 to x100, y50. Or extrude at the rate of 10 millimeters cubed, or it's a bunch of commands that the slicer is telling the printer how to print. And so that's the output of the second step, is then a file that we can actually put into the machine itself that has the steps to follow. So then finally, we're actually now printing the model that we created and then sliced. And so this is the machine itself following the instructions we gave it from the slicer that is depositing our material onto a build plate of some sort. There's build plates for the machines, and we'll talk about this more next week. There's some choices we can make about what you're building onto that make it better for some purposes. Sometimes we'll print onto plaster. Again, sometimes we'll print onto like an existing clay slab, and I'll show you how to make that work when we get to that point. Typically for the 3D printers, if you don't know what to print on, printing onto the craft paper like what Arena has, that actually works really well because then you can just slide the model off when it's done. Sorry, I missed the software for the slicers. There are a couple of slicers that everybody in the 3D printing community seems to use. They're all open source. Prusa Slicer is the one that we're going to use. It's made by one of the 3D printer companies that seems to value contributing to the open source space. It's one of the reasons that I like it, but also one of the reasons that it's more powerful is that a lot of people are adding things to it. The original slicer is slicer spelled with a 3. Some people like to call this Slick 3R, just to make it not confusing. This was the first open source slicer that came out in the early 2000s, as kind of 3D printing started to find its feet. Again, this was all created for plastic 3D printing, but you'll find from this class that 95% of what we're doing will be applicable everywhere. So by the end of this class, if you want to go on Amazon and buy one of these 3D printers, you'll be able to run it. There's not a lot conceptually different between printing plastic and printing clay, other than some of how the machine operates. Obviously, extruding clay is a little bit different than extruding plastic, but all of the steps up to there are nearly identical. So, any questions? This is like the 10,000-foot view of where we're going in the next 3 or 6 weeks. So for modeling, we're going to look at Fusion today, and we're going to look at Blender in week 3. And then we're going to revisit those two with some more advanced concepts once as we start getting more comfortable modeling and then printing the things that we've modeled. We'll get to that on the last week of class. Slicing we're going to cover mostly next week when we learn how to operate the machines. So the plan for next week is to take some of the models you've built either today after I'm done with the demo or throughout the week until next week. We'll bring those back in, and then we'll learn how to slice those, and then we'll learn how to load those onto the printer. Get the printer set up, and then actually print at least a couple of the things that you guys have. And then, yeah, we'll talk a little bit about 3D scanning. So how do we get something from the real world into Blender? That'll be one of the weeks. And then, as I said in my email, one of the weeks, I think it's week 4, I will be out of town. Lee will be around though, and I think Lee's plan is to talk a little bit more about like what are the artistic approaches that you can use here. So, just so you're a little bit of my background, I'm a new ceramicist. I've only been doing this for 2 years now, but I'm an engineer and have been doing 3D printing for more than 10 at this point. My wife and I help coach a high school robotics team. So a lot of my knowledge here comes from making parts for the robot. So a lot of Fusion, not as much Blender, but you get a little of both just doing that. So,
Cool.
All right, 10,000 foot view. I'm going to jump into Fusion. So let's get Fusion open, and we'll start with making the simplest form that we can make in 3D. So we're recording the screen. So you should have something that looks very similar to the screen that I have in front of me now, which is basically just a blank screen. The thing that I want you to notice before we even start doing anything is that up at the top right here we have this kind of cube. This will always be here, and it is a representation of how you are looking at the space inside the modeler. So if you are ever lost about how you might have your model oriented, this is where you should look to see if you have it in some kind of weird rotation or something. And if you ever get completely lost, if you mouse over that cube, you'll see there's this home button here. And clicking that will always bring you back to the default view. So you can never completely break what you're looking at. You can always go back to this home position.
So I see you can click on that cube and just...
Yep, so if
go
you want to
all
look
over
at
the
just the
place.
front face or just the right face, that's where you would click to have a completely orthogonal view. Irina, I'm going to get started just a little bit. So in Fusion and in most of these parametric modeling softwares, the whole idea is that most of the work that you do is still going to happen in 2 dimensions. So you'll start with creating a 2-dimensional representation of something about your object. It is generally like a slice of your object or one plane of your object, depending on what tools you're going to use. And then from there, you'll use the tools in the software to then transform that into something that's 3-dimensional. So almost always the first thing that we're going to do when we're in this blank slate here is that up at the top left, we want to be in solid mode because we are designing a solid object. And we want to be in design mode because there are other things that Fusion can do besides design that we're not going to worry about. But the button we want to find is this button in the top left called Create Sketch. It looks like a green plus with some points and edges on it. And when you click that, what it's going to do is it's going to display the 3 potential planes that you can start your sketch on. So you can start, a sketch from the YZ plane, like if your sketch was standing on its side. You can start it from the YX plane, so that would just be from the other side, or you can start a sketch from the ZX, so that would be kind of looking down on your object. You might want to pick a different one of these depending on how you're envisioning the construction of your object, right? If I'm thinking about sketching an object starting from the side of it and then doing something to it, I might want to start my sketch on the YX plane. If instead I'm thinking about starting from the bottom of my object and growing it upwards, I might want to start from the ZX plane. It's kind of the ground, right? So for what I'm going to make, I'm going to start on the ZX plane. So now I'm kind of looking straight down on whatever object I'm going to create. And you can see again up in the top here, you can see we're looking at the top of whatever it is we're looking at. So now that we're in the sketch space, Fusion has given us a bunch more tools up at the top. So these are all the 2-dimensional creation tools that Fusion has in order to start making 2-dimensional designs. If you want to move this space around, if you click and hold with the middle mouse button, and this is why I said it is useful to have a mouse, Yeah, so if you want to pan around, it is the middle mouse button that lets you do that. If you click that and hold, it will let you move around in space. I'm doing a very simple example here just to show you going from two-dimensional to three-dimensional space, and then we'll get more complicated as we start exploring more of the tools. So up here on the top left are the tools that create new parts of your sketch. A lot of these have hotkeys, so sometimes you'll see me not clicking these buttons. Instead, I'll just push the button on the keyboard that corresponds with them. If you want to know what the hotkeys are, if you click this Create dropdown, it gives you all of the potential creation options. And so you can see if you want a line, you can hit L, and it'll put you into line mode. If you want a two-point rectangle, you can hit R. That'll put you into two-point rectangle mode, which is where you click the top left and the bottom right in order to make a rectangle. There are some other ways of making rectangles that Fusion has available, like the center rectangle, where I can click where I want the center of a rectangle to be and then what the bottom point is. That doesn't have a hotkey, so if you want that, you have to go into this menu to get it. Same with circles. So a normal circle where you click the center of a circle and then it define how big the circle is, that's C for circle. But there are other ways that you can define circles. You know, you can have 2 points on the circle. They're all in this menu. And you can see
the reasoning behind choosing the points is how you can then work with it after.
Exactly. Or how it fits with the structure of the sketch that you're trying to make. So I'm going to make a rectangle down here by clicking that rectangle button. I'm clicking on the origin, which is that kind of target point that's the middle of our drawing, and then I'm just dragging down. And you notice before I click again, it's giving me the option, although I don't have to take it, and you'll see why in just a second, to define how big I want the sides of this rectangle to be. Fusion defaults to millimeters, but you don't have to use millimeters. For reference, the smaller of our 3D printers can print a 100 millimeter cube. The bigger 3D printer can print a 180 millimeter cube. So when you're thinking about what are the things that I might want to print, try to keep it inside those dimensions, or perhaps quite a bit smaller, right? This will take 2 hours to print, but something like this took about 20 minutes to print. So you can see these boxes come up where I can define how big I want my shape to be. So maybe I want a 50 by 50 by 50 cube. That's what I'm aiming for, just as an example. So I know this first side, I want 50 millimeters. And then I can hit Tab. That's going to bring me over to the other side. So I can type in 50 millimeters here. Now, like I said, you don't have to work in millimeters if you're more comfortable with inches. Fusion is perfectly happy doing the conversion for you on the fly. For example, if I wanted this to be 3 inches, if I just type in 3 inches, Fusion will do that for me. So, and if I hit enter, you'll see it'll actually convert it back into millimeters. But you have the option of thinking in inches if you want to. Now, you'll notice I wanted a 50 by 50 by 50 cube, but I've screwed up one of my sides here. So I can change this dimension after the fact. If I just double click it, you can alter it to whatever you want it to be. So now I have a 50 by 50 square. It's not a cube. It's two-dimensional.
Does it always have to be centered at 0, 0?
No. In fact, most of the time you don't want it to be centered because you might be building something bigger. And we'll get into this in just a second. When you don't have anything else as part of your model yet, the only point of reference you have is that origin point. So if you want to constrain things, that's the only point that you can start with to start constraining things. And I'll show you what that means in just a second. So I have all of what I need my sketch to be. So once you're happy with what it looks like in 2 dimensions, you can hit either Finish Sketch down here in this window, or up on the top bar, there's this green check mark. Both of those will do the same thing. That's telling Fusion, I want to exit 2-dimensional mode and get back into 3-dimensional mode. And it'll kind of spin you around back to the home position. So now you can see that square that I made in 2 dimensions exists now in the 3-dimensional space of Fusion's modeling world. When you are in 3-dimensional space, if you want to rotate and see your sketch from a different angle, if you hold the right mouse button down, you can see that your cursor will turn to these rotating arrows, and you can drag around to move your sketch around if you want to see it from a different view. And this is where that cube in the top comes in handy, because if I do this, I don't really know what I'm looking at unless I look at the top cube. So it's always good to keep that in mind too. So I can always click the home view and go back to the home view.
And you've got your functions on the bottom, or at least I see it, I have functions on the, I can hit that orbit.
That's
on
right.
there.
Yeah, so that might be the way to do it if you're not using a mouse, is yeah, if you want to orbit or free orbit, you can click down there and move it around. So now we're going to use the first of the transformations in 3 dimensions to get our square to be a cube. And the first one, and the simplest one that we're going to use, is called the extrude command. And what this does is it takes a drawing that you've made in 2 dimensions and move it in one axis straight in a direction. So you'll see that's up here. It looks like a cube with an arrow facing up. And sometimes Fusion will try to guess what you want to extrude. Most of the time it's the last thing that you drew. We only have one thing, so that makes it easy for Fusion to guess what we did. But just in case it doesn't have that, sometimes it'll look like this. And you can just click on the region that you want it to extrude, and it will start. It'll give you this arrow so you can see the direction that it's going to extrude in. And then just like when we were defining the dimensions of our rectangle in 2 dimensions, it is now asking us how far do we want to extrude in this direction of the arrow. And so we can type this in here. If I want a 50 by 50 by 50 cube, I can type 50 in here. And now we have that extrude done in 50 millimeters off of where we started. And you'll see there's a lot of options here. These will start to make more sense when we get more complicated shapes. And we'll get into what we might want to change these to a little bit later when we get into the intermediate versions of using Fusion. We might get to some of it today depending on how far we get. Another thing to notice is the last option that we have in this menu is called operation. And that is you telling Fusion what you want to do with this shape. By default, it's going to create a new shape out of it that's new body. Body is a 3-dimensional shape. That's how Fusion calls a 3-dimensional shape. But this might not be the first thing that we drew. Maybe we're drawing this to add on to another drawing that we've already made. So there's some other options here. So we can join this to something else that we've made with the join operation. We can use this to cut away at something we've already made. So maybe we want this cube to slice off part of some other 3D model that we already have. So we could use cut. Or maybe we just want where both of those two exist. That would be intersect.
And all this menu is there at the top, or?
So this side menu pops up when you are in the middle of doing an extrude. So when you click that extrude button, and then click your drawing, it's going to pop up that menu. It starts on the right side, but you can move it around if you want to move it around.
Now, if you're going to do a function other than the new body, is that built in this same space, or are they?
Yeah, so you'll draw it and extrude it the same way, and we'll get there. We're going to do some joins and some cuts.
It's interesting because it offers the option like solid extrude and thin extrude, right? Like, right? This is. And
so we're going to stick with solid extrude. We'll get into what thin extrude does during the intermediate portion, but it turns out most of the time you don't need to use that for what we're doing. So once you're happy with what you've extruded, you can hit OK, and Fusion will complete that extrusion command. And so now we have a fully fleshed out cube in 3-dimensional space. So now that we have something that actually will show up in the rest of the Fusion UI, I'm going to walk through some of the other ways to get at these shapes and some of the functions that make Fusion useful. So over here on the left side, we have kind of this tree with a bunch of drop-down menus. If you notice, one of them is called Sketches. So if I drop that down, I have two because I restarted one when we restarted with Arena. But you'll see that this, if you click that eye, that will open back up the two-dimensional sketch that we made. You'll see it here at the bottom of the cube, and I can hide it or show it. When you do a three-dimensional command, Fusion will automatically hide the sketch that it's based on. Sometimes that's useful, sometimes that's annoying. I go back and forth. But if you want to see it, just know that you can always go into this Sketches folder and turn off and on any of the sketches that you've made. If you have very complicated shapes, you can have dozens of sketches, so sometimes it's useful to start hiding them, just so your view doesn't get too busy.
And the sketches mean in 2D, right?
The 2D, yeah. So Fusion refers to sketches as two-dimensional drawings, and then bodies as three-dimensional drawings. So you'll notice there's another folder for bodies, and we have an object in there now because that is what it was the result of our extrude command. So now let's do a new thing. Let's create a new sketch. So we're going to click the Create Sketch button. And instead of clicking on one of the faces that starts at the origin, if you have a flat face as part of a body, Fusion will let you draw on that. So let's click on this top part of the cube and start a two-dimensional drawing from the top of the cube.
Now, does it make that cube, so that is now a sketch, that square?
That
is now, because you clicked on that plane of the cube.
Yes, so now you can see in my sketches, I have a third sketch. And you can rename these if you want them to be less confusing. So like, I can, if you right click, you can say rename. So like I could call this cube if I wanted to. And I could call this sketch, this is the one that created our square, so I can call this square. So now this is an opportunity to envision what do we want to do to our cube. We are creating a sketch to make some alterations to it. So maybe what I want to do is I want to create a circle in the center of this square to hollow out. Because maybe my vision for what this shape is that I'm going to print is a square outside with a circle middle. Right? This is a shape that would not be easy to do with the traditional techniques that we have in the studio. We can do either one of those things, and this is something that Lee will probably say multiple times. If you just want a cylinder, just throw a cylinder on the wheel. If you just want a square, just build it out of slabs. You can do that faster and probably more precisely than what you'll get out of the 3D printer. But when you start getting into these concepts of, well, I want a cylinder, but I want it to be twisted. Or I want a square, but I want part of it to be a circle. Now you're getting into the realm of, well, maybe it is easier to print that and start from that as a shape. So that's one of the reasons that I wanted to go down this route. But this is also an opportunity to talk a little bit more about the tools that we have in the two-dimensional space to start adding some constraints to how we draw to be more precise, right? Because what I want is a circle in the very middle of this square, right? So what I can do is you'll see Fusion will highlight the body, but this is not part of our sketch yet. We need to tell Fusion, hey, I want to make a reference to this body in my sketch. And we do that using the project function. And so that's in the Create menu. You can see down here, Project Include, Project. And what that does is it's basically like shining a light on your object, and where it hits this new sketch that we've created, it will give us an outline of where that exists, right? And the hotkey for it is P. So you can always just hit P. And so now Fusion's going to say, all right, what is the thing that we want to project? We can click the cube. And then if we hit OK, you'll notice that Fusion has now added in the points of the cube, and it has also added in the edges between these points so that we can use them in our sketch, which is very useful. So this is the way that you can take other parts of your model and add them in two-dimensionally. There is one other way to do a projection, just because I assume that you will be thinking about this in the back of your mind. If instead of what you want is that like light shining a shadow onto your drawing technique, if you have a plane, a two-dimensional drawing plane that is intersecting an already existing three-dimensional object, you can also tell Fusion, tell me where the line of that intersection is and project that, and that's the intersect command.
So when we say project, does it mean project to or project on?
Yeah, so you are taking whatever object you have selected as the project in the project function, and you are projecting it onto your two-dimensional drawing plane,
Okay.
right? So the idea, right, is if I have a cylinder, and now my plane is here,
Okay.
right? So if I project that, what I'll actually end up
Yes,
with
yeah,
is a rectangle.
yeah.
Yeah.
So in our case, did we select something to project into this?
So we're in a drawing, right? When we clicked Create Sketch, it created a plane on that top face that we clicked. So it's a two-dimensional plane that's parallel to the ZX plane. And we projected the cube onto that,
Okay.
which is now, again, a square.
Yes.
So, but it could get more complicated, right? So far, we've only worked with drawings that are parallel and in 90 degrees, or these are exactly parallel. But it doesn't have to be, right? We could have a plane at any angle depending on what our model looks like. So then projection gets more important. Or you might want to use intersect depending on how you're building it. And I have found that this is the real truth of most 3D modeling, is that it feels almost to me like a logic puzzle of like the shape that you're trying to get to, and figuring out the commands that you need to tell Fusion to get there. There are usually 3 or 4 or 5 different ways that you can get there of like, all right, like I know this is a cone, but a cone is really a triangle, and a triangle is really this, and the points of this triangle would hit here on this other shape. And so you're just kind of working backwards to like, how do I get down to the simplest form of what this means, and then put that into Fusion, and then build back up. So.
I still don't quite understand, when we are projecting the cube and like this shape, the square into the cube.
Mm-hmm.
So are we looking at some intersection, or like we're interested to cut the inner part?
So right now it's not an intersection because the plane that we're working on is actually on the top of the cube. We could have a plane inside the cube and use the intersection command.
Okay.
We could also still use the project command even if it is intersecting. It just won't do necessarily what you think, right? Because it's a shadow.
Okay.
So you'll get maybe some weirdness from both sides. But please keep asking questions because I don't want to lose you. So the next thing I want to talk about is the concept of construction lines. So construction lines, which you'll be able to get to over in this sketch palette on the right when you're in two-dimensional space. You'll see one of the options here is line type, and there's a toggle for construction. And what this tells Fusion is, I want these lines in the drawing, but they're only here to serve as reference points for other things that I want to draw. Don't include them when I am using the three-dimensional transformation tools, because I don't want these to be part of what's being transformed. And the reason that we're using construction lines here is we're going to use them to find the center of this cube. Right, so the first thing I'm going to do is I'm going to draw a construction line from this point to this point. So now we have an edge in construction space that connects these two. And the reason why we want to do that is that a function that Fusion has built in is that it will automatically tell you where the midpoint of a line is. So the next thing we want to do is if we mouse over this, you'll see when I hit the midpoint, and it'll always snap there, Fusion will bring this little triangle icon up. And that means that your mouse is at the midpoint of the line we just made. So I'm going to use the line tool. I'm going to make sure that the line type construction is checked on, because again, I don't want to include this line in whatever transformation I'm doing in three-dimensional space. And I'm going to connect this point to this point so that we have a construction line across where this edge is, so that we can use it to find the midpoint. Then, still in the line tool, you can try to guess, and Fusion will typically snap to it, but you can just walk along it until you see that triangle show up. And that is Fusion telling you that your mouse is currently at the midpoint of whatever the thing is that you're looking at. So I'm going to click that to start from there. And I'm just going to drag down. Fusion will try to snap it to 90 degrees, but I'm going to make this intentionally very bad just to illustrate what we can do with Fusion. So when you are making a line, just like when you're making a rectangle, you'll see that Fusion's going to give us options for if we want this line to be of a particular length, or if we want this line to be of a particular angle from the line that we started it at. So you can see right now Fusion is saying this line is 50.9 millimeters and 100 degrees. I'm not going to define these. I don't need to. So I'm just going to click over here on the other side of our projected shape. And you'll see Fusion has given us this orange dotted line. That's a construction line, just to separate it from the idea of something that's not a construction line. So now I want to introduce the next concept in two-dimensional space, which is called constraints. And those are all contained in this middle section of our drawing panel. And this is how we tell Fusion what constraints do we want to have for this line that we just made. So that would be things like, Fusion, I want you to guarantee that this line is always connected to some point. Or Fusion, I want you to guarantee that this line is always tangent to this circle. Or for the example that I want to do here, I want to say, Fusion, please guarantee to me that this construction line that we've made is always perpendicular to this other construction line that we've made.
So that's after the fact.
Yeah, so it is not only not necessary to draw precisely in Fusion, sometimes it is better to draw not precisely to make it very obvious that it is not already constrained, and then constrain it. I will find myself doing that very often. Like if I want a line that is tangent to a circle, I will draw it wildly non-tangent just so I can see it snap into place correctly. And you'll notice that when we made that constraint, Fusion turned that line from orange to black. And that is an important concept to notice when you are in two-dimensional space. Construction lines will either be orange dotted or they will be black dotted lines. Always dotted for construction lines, but the difference is that when you have a part of a drawing that has as many constraints as it needs for Fusion to know exactly where it is in 3D space, it will make it black. And the reason why Fusion knows that now is that there are enough constraints that we told it that we don't need to define anything else about this line. Because now, with this triangle, and I'm going to zoom it in just so you can see it, this triangle here says we've told Fusion that this line starts at the midpoint. So Fusion knows that this line has to be in between these 2 points. When I made that weird dotted diagonal line, I clicked this other edge here, right? And that told Fusion, I want this line to always be connected to this other edge. And finally, by making it perpendicular, Fusion knows that it has to go, 90 degrees. That is all Fusion needs to know to, there's only one line that can satisfy all of those constraints, and it's this one. That's why Fusion turned it black. If it is not a construction line, if it is unconstrained, it will be blue. And if it is constrained, it'll be black. So it is not required for all of your two-dimensional drawings to be black. You can leave some things unconstrained. They don't have to be constrained. Just know that if they are not fully constrained, it means that there is some way that you can move that drawing that would also satisfy whatever you've given Fusion. Once as it is black, it's locked in. Like there's nothing that will be able to move it around. It is a fully defined sketch. So it is a goal, but not necessarily a necessity. So now what we want to do is we want to add a circle that is in the middle of this line, right? Because if we know that this line is in the middle this way, the midpoint of this line will be the center of the square, right? So I'm going to say create circle, and then just like before, I'm going to mouse over until I get the little triangle icon. And then I can click to start my circle and then make a circle. Now I know that my cube is 50 millimeters, and so I don't want to make my circle too big that the walls of my shape will be too thin and it would fall apart, right? So maybe I want my circle to be 45 millimeters or 46 millimeters. That would give us a wall that is, 4 millimeters. That's probably fine. So then we'll hit OK.
What's from your experience, what's the kind of the minimum?
Usually an 1/8 inch, so like,
For you?
yeah. Somewhere between 3 and 5 millimeters is usually appropriate.
Okay.
And notice I've made a mistake here in that when I made the circle, I still had the construction line type turned on. And I don't want that, but we can fix that. So if I click the circle to select it, you'll see over here the line type is selected as construction. I can actually untoggle that while I have the circle selected. It'll turn it back to being solid. And you'll notice that the circle is now also black on the drawing because the line was already constrained. And the midpoint of that line is necessarily constrained. So a circle defined off of that constraint is also already constrained. So that circle exists only in one place.
So it's interesting because when I try to find a middle of this point, so should I hit the click the midpoint first and then?
You could do it that way. So I'm using that little shortcut where it just tells you where the midpoint is, but let's do it in a way like we don't get to have that. I'm going to remember to toggle off line type this time because I don't want to have to unconstruction line it. But so let's make a circle. You'll notice when you're just making a circle in space, it's this vertical horizontal crosshairs. When you are over an edge in a drawing, it'll turn to an X instead of a plus. This is Fusion pre-applying the constraint of I want this circle to always be connected to this line, which is the same as this coincident constraint. Coincident says these things should always exist together in some way. So if I go over with the circle and I make a circle just somewhere on this line, right, you'll notice that, and I'm going to hit escape because I don't want to make any more circles. You'll notice that the circle is blue. Like we talked about, that's Fusion telling you this circle can exist in more than one way in the drawing. And in fact, we can tell because if I click on the circle and drag it around, it can be both bigger and smaller because I haven't given a dimension, and it should also be able to move up and down. So it is unconstrained. I can't move it left and right because it has that coincident constraint that I've told Fusion that it needs to exist on this line. But I can move it up and down on the line, and I can make it bigger and smaller on the line, right? So we'll actually learn two things now. The first is we can learn about that midpoint constraint. So now let's tell Fusion that we want this circle to be on the midpoint of the line, right? So we'll click the circle. So that's the first thing. And now we need to tell Fusion which thing do we want it to be on the midpoint of. I want it to be on the midpoint of this line, right? So now we have that midpoint constraint. Just like what comes up when it shows you the triangle, again, that's just Fusion pre-applying one of the constraints that we have access to. Just because it's something that you, as a designer, you do all of the time.
Gotcha. It's making it,
It's
giving you
trying to
access
make it
it
easy for
without
you.
having anything
Yeah.
else. Okay.
But notice, it's still blue. And that's because when I made the circle, I didn't type in what size I want it to be. If you don't type it in, Fusion will just do whatever it is when you clicked on it. But Fusion knows that could be an undefined value. The way to define the value of something in Fusion after the fact is with the dimension constraint I guess it's not a constraint. It's under the Create menu, but it is called Sketch Dimension. And it is this thing that looks like an arrow between two lines. The hotkey for it is D for dimension. You'll probably be using that a lot in Fusion. And that just tells Fusion, hey, I want to make this a certain size or length. So I can say, all right, I want a dimension on this circle. And you can see right now this circle is 22.7 millimeters. But when I click, it'll give me the box. So now I can say I want this to be 45 millimeters. Hit enter. Now it's a 45 millimeter circle. And now it's back to black because it is both the midpoint of the line and it's a size. So there's nothing else that we can do with the circle besides those two things.
It's just a way of thinking.
It's a way of thinking about how much do I have to tell this software for it to know what I am trying to describe. So now we have a circle on the top of our cube. That's all we need to do for now. So we'll hit finish. And I'm going to go back to the home view so I can see this in 3 dimensions, just to see what we've done.
And how do we go to the home view?
So up at the top right, there's this cube, this view cube on the top right. If you mouse over it, you'll see that there's a house button. And if you click the house, it will bring you back to the kind of default view. So we're going to use the extrude command again. And we're going to click on the circle that we just created. Notice that Fusion will give us a couple options based on this drawing. I could actually extrude anything that's enclosed by a drawing. So I could choose to extrude the outside of this circle instead of the inside of this circle, which could be useful, right? Or it's just a different way of constructing something. For example, maybe I wanted a really thick, solid bottom, and then I wanted this cylindrical cube thing to extend beyond just the outside. I'm going to do it the other way. I want this circle. I clicked the wrong thing. I want to extrude this circle, but I want it to extrude into the cube. And Fusion will default that if you start extruding into something that already exists, it will default to a cut. So if this arrow's facing up, right? So if I extrude in a negative direction, so let's say I know my cube's 50 millimeters. If I extrude negative 40 millimeters, you'll see it turns red, and the operation that it's defaulted to is cut.
It's not that whole. Oh, I guess whole goes to the other side. Sorry.
We could do it all the way, right? So like if I extruded negative 60, you'll see that it actually goes all the way through.
Does
So you
that-
could do that.
Does it consider what's beyond the cube positive, or is it?
So the direction is based on the arrow when you start. Or if you look at this view cube, the positive direction is the positive that these axes are facing.
Maybe I said it wrong. Does it, since it's going through the cube, but it pops out the bottom of the cube? I guess we haven't gotten to a point where this is actually a hole.
That's right. We haven't hit
figured
OK
that out
yet.
Okay, we don't.
To answer your question, it will not start creating geometry after the cut.
Gotcha.
So it will only do one of these operations. It will either cut, or it will join, or it will create a new body. It won't do those all at once. We could do that. And in fact, I'll do it to show you.
Okay.
It won't be printable, but it's an interesting example.
Gotcha. Okay.
So let's do this cut. So we're going to cut all the way through, just as an example. So yeah, now we have this cut all the way through our cube, which, I mean, that could be interesting too. Maybe this is part of something you want to add to a larger sculpture, right? You don't always have to print finished pieces. Maybe this is a small piece that you want to print 10 of and put onto something, which could be cool.
I want to see the ways that it can go wrong on
Yeah.
you too is just as good as how they go right. Probably more important.
Yeah, so notice that Fusion, again, by default, hides the sketch that you use with the transform tools. But just to your example, I want to bring it back just to show you that you could, if you wanted to, now use extrude again on that sketch and then make something else, right? This wouldn't be printable because this doesn't connect, right? Like this is a weird edge right here. But you could do that if you wanted to. And I'm going to show you this, but Don't worry if this is a lot all at once, because we'll do this more in the intermediate class. What I did was extruded out the top, but to more fully answer your question, what if I wanted to cut and then start making material after? I don't have to make a new sketch on the bottom. I can tell Fusion that I want an offset from the sketch that I have. So because these planes are parallel, if I click this circle and click extrude, notice there are some more options here. And one of the options is start. I can either start from the profile plane, that's where my sketch actually is the profile plane. But I can also start with an offset, so I could tell Fusion I want to start from -50, and so now it's going to start extruding from down here, so I could do that. The other thing that I could do instead of offset is that this is a newer feature of Fusion, is I can also tell it that I want to start from another object. So I can tell Fusion I actually want to start from this face, and it'll do the same thing and just calculate that offset for you. So you can achieve what you were asking.
Can we replicate like this extrusion circles from all the planes we have?
Yes, but you would have to do it with multiple drawings.
I see. Okay. So.
Or there's another way to do it that we'll get to in the intermediate thing. There are things called array functions, where you can select a feature that you've made and then have it do it multiple times.
Is there, like, for example, what if you wanted your circle, your column, to get halfway minus an eighth and then halfway minus an eighth the other way? Is there a way to project that circle onto the sketch, the first sketch that's just a cube, or do you have to build it again?
So that was that offset.
So I could
exactly.
take the offset.
Yep.
You can do it twice, so you could do the one way and then you offset it.
You can always you can use a sketch and the transform tools as many times as you want.
Okay, cool.
Again, it hides them by default, but they're not gone. They're just hidden. So you can always bring them back with this eye, closed eye, open eye. So now if I close the eye, like, it's not selectable because it thinks that you're done with it. You used it and you made a thing, but you can always click that eye again and then use it again.
So the sketches conceptually are just like a function that on top of the body. So it's like a way that you're affecting the body.
Correct.
Or
it is a way on the path to affecting the body. Bodies are created using the three-dimensional transforms like extrude, but we're going to explore some more of them in the next half an hour. Okay. But the transforms need a two-dimensional shape to transform. So the sketch is what provides that two-dimensional shape, and then how the bodies interact is based on that operation. I could join them, I could cut them, I could intersect them.
Is it okay, like at this point when we did it, let's say you want to stretch the cube, change the dimension.
Yeah, so I was just going to get to that, and that is one of the powerful things that Fusion does that Blender cannot do, and that is why this is called a parametric modeling program, because everything that we've done so far, we have done by giving Fusion a bunch of parameters. It's parametrized, and you'll notice at the bottom left down here, there's this little timeline of all of the things that we've done to our 3D model. So you can see you've created a sketch, you've used the extrude transform. You created another sketch, and then you've used another extrude transform. So I can go back on this timeline, go back in time, and change these things, and Fusion will recalculate the model all the way through that. So I can go back to my original cube, right, which is 50 by 50, and let's say I wanted it to be bigger. I actually want it to be 70 by 70. Oops. 70 by 70, and finish that sketch.
And because
Fusion
you constrained that to
exactly.
center.
It still knows it's the center because I didn't give it measurements. I just said make it the midpoint. So it's still going to be the midpoint. In fact, if it was a rectangle, it'd still probably work.
But if you placed that without constraints, then it would have just expanded on
Right, so that
Yeah.
now maybe it's not in
it's
the
not
center
center.
anymore. And that's why Fusion tries to give you that hint when it makes it blue to say, hey, this isn't fully defined, so if you change a parameter, I don't know what's going to happen.
Okay, okay, that makes sense.
I will caveat this, that the parametric nature of this has an asterisk in that if you make too big of a change that either removes some constraints or puts Fusion in the position that like what you've now done is not physically possible down the line, it will do its best to get as far as it can, but you can still break it. It's not infallible. But most of the time, if you've done a good job keeping everything fully constrained, you can change pretty much everything about your model at any point along the chain. It's very useful.
So the flip side is, if you were to take this into Blender, you would be just picking in points and
Correct.
making adjustments on points, not
Yeah,
math of it.
exactly, yeah. So that's the way that I like to think about it too, is that Fusion is creating the 3D models using mathematical equations. Blender is using it using a storage of where all the points exist in space. Blender can't do this because it's not based on equations. There's still an undo function in Blender. You can always go back in time, but you can't change a part of it and watch the rest of the parts change around it. And just like we changed the sketch, you can also change what you did on the extrusion. So I can double click that. It gives me back exactly the same thing. So maybe now I want the cube to be, I don't want it to be a cube anymore. I want it to be a weird flat thing. So I'll only extrude 40. And it still operates correctly.
Now, if you were to change the plane where the circle is to a rectangle where the sides are shorter than the height of the circle, would it give you now two shapes?
That's a good question. Let's try it. So yeah, let's have this circle now be bigger than the thing that we created, right? So we'll go in, we'll parametry change this. It's now given us 4 shapes.
Okay.
Because
but it still has the geometry.
Yeah, it's
still accessible.
like I said, it's trying its best.
It's cool.
Yeah, so it's all still in there, and I can go back in and be like, oh, that's not what I meant. I did not want it to do that, and then it's all in there. It's completely non-destructive.
It's very nice that you can actually edit it.
Yeah, on the fly. Yeah, it is one of the very cool things about what Fusion can do.
So how far of a path? I mean, would it literally be 1,000 steps?
It could,
So-
yeah. This can go for.
And so that's maybe that. So you get huge files. when
You are,
store that?
yes.
Okay.
There is a reason why when you're in industry, CAD computers are nearly supercomputer level, because when you're doing things like trying to model the engine block of a car, yeah, you could have 2,000 sketches and 5,000 steps.
Okay.
I don't think we'll ever get that complicated here, but yeah, you are constrained by how good your computer is at that point.
It starts chugging a little bit.
Oh yeah, you'll see it. And you'll see it way more in Blender than you'll see it in Fusion. Blender is a pretty heavy program just because it has to keep track of millions of points. One of the tricks that we'll talk about when we get to Blender is that when you're modeling in Blender, you typically want to model the simplest shapes you can until you have to make them more complicated, just to get around that, right? Like if I want to make like this vase, right, I'm not going to put in all of the points that made these little facets until the very end. Because if I'm just working with it as a cylinder, I'm going to make it as simple as I can just so my computer doesn't crash.
Yeah. So the complexity comes to you work it so the complexity's at the end of the process, so that and you have a plan by then. Or
Exactly.
whatever. You're not trying to deal with the shape or the overall structure when you're working on the whatever.
And you can do that in Fusion too, yeah, because as you start adding things, it'll get more and more complicated. And again, that's when you start turning off sketches or bodies that you don't need, so it doesn't have to worry about it. Any questions so far? We've got 20 minutes left. I can explore at least one, if not 2 more of the 3D transform tools. We'll probably talk about Revolve because I think it is the next most useful of the tools that we have, but we'll eventually get to all of them. So my original plan was that I would demo for an hour, and then you'd have an hour to play around. But I feel like, yeah, we've been playing around, so.
No,
Just
this is good.
like we are a very small group.
Exactly, yeah, we're free form here.
Yeah.
For me, it's very helpful.
Yeah.
You're not going to learn it all.
Yeah,
today.
so-
I don't-
No, again, you can get whole degrees in this,
Sure.
so don't feel like this is something that you have to do
We're
right
I'm
now.
blown away by the cube and a cylinder.
Yeah.
So
And this is already a useful shape, right? Like you can see this being applied to something that you would, make somewhere else. Print 10 of these and stick them all over and be a weird sculpture. So I'm going to close this so that we can start a new 3D model. You are welcome to save it if you want this for later.
is there a way, so if I were to save it, is that something then you could import when you're working down the line to?
Yeah, let's talk about that. Let me reconstruct this real quick, just so that we can talk about that.
Because you talk about having multiple shapes, right? So let's say, hey, oh man, I start building a repertoire of shapes that I want to use in my whatever designs or something like that.
Yeah, let me rebuild it real quick just so I have something to save. No, you're okay. I should have saved it. So okay, so I have a shape again, right? So I can click Save up here, and Autodesk, out of the graciousness of their hearts, provides you 10 spaces on their own servers to save things. So you can save things to the cloud if you want to. You don't have to. The other way to save something is that if you can notice in the bodies, I can go into here and say Save as Mesh. If I right-click on the body, I can go to Save as Mesh, and that's where we're talking about these files that get created, right? So I can see I have choices of formats. I can save it as a 3MF. I can save it as an STL. And then if you hit OK there, down here you have an option to save it on your computer. And so now you can save it to anywhere, and then you can re-import this later using the open function, and it will reopen that. And then
And
you
it's
can keep
opening
working
as
on it.
its own space, or can you import it into?
You can also import it in as another body and we can talk about that in the intermediate steps. And we'll actually do that when we're talking about like how would I grab a 3D model off the internet. So
So it's like it doesn't give me the option to save as just to save.
right. So the two things that you can do is you can either save it to their cloud, or you can export a body as an STL. So that So there's the location.
And you would go STL over 3MF?
I would go 3MF over STL. You can also save it as a Fusion file. So in your case, where I know that what I want to do is use it as an object in Fusion later, Fusion will save more information about it in its own format than as an STL. So if you know that's what you're doing it for, I would use the export command and then save it as this Autodesk Fusion archive file in F3D. Just know that the only thing that can open that is
So
Fusion.
you're going to have to re-save it.
Yeah,
if
so
you're gonna-
you're not going to be able to slice an F3D. You can slice a 3MF. So yeah, if you want to save it for later, you would have to reopen it and then save that again as a 3MF, which is fine. That's not a big deal. But
with what we're doing with it's
yeah, an F3D is a dead end of just the modeling part. All right, so I'm going to close this for real this time, and we'll talk about the revolve function. So like extrude, what revolve does is it takes a two-dimensional sketch and it transforms it into a three-dimensional shape. Unlike extrude, which moves the shape in one dimension to create a three-dimensional shape, revolve will spin it around an axis to make a three-dimensional shape. So this is very good for round things. Almost all of this stuff started with a revolve command. And it lets you create some pretty interesting shapes because it doesn't just have to be a cylinder, right? Exactly. So, and this is, like I said, some shapes you might want to start in the YX plane instead of the ZX plane because now most of the time you're envisioning these kinds of shapes from the side, right? So I'm going to start a sketch in the YX plane. So now I'm looking at it from the front. And you have to think about the fact that this is going to be spun. I don't want to create the whole profile of the vase, right? I want to create half of it. So let's say I want to create a vase that has a top that's 25 millimeters, right? So I'm going to use the line tool and create a line that's 25 millimeters. Again, I've done it intentionally badly, so I can add constraints. There's a constraint called horizontal vertical, so I'm going to constrain that to be horizontal. I want the bottom to be 40 millimeters. That already got automatically constrained. And I want the distance between these points. I don't need to create a line, so I'm using that D hotkey again. And I'm going to click this top point and this bottom point, and that's going to give me how tall I want it. I want this to be 50 millimeters tall, right? So now, right now my sketch is 2 lines, one of which is 25 millimeters long, one is 40 millimeters long, separated by 50 millimeters. Now, I'm going to use one of the tools that we haven't used before. This is a spline. This is what lets us create arbitrary curves. They're not arbitrary, they're still a mathematically defined function, but it lets us create more interesting shapes than just a straight line. So I'm going to start at this point. I'm going to tell it where I want to go into space, and then the next thing I'm going to be able to do is how much I want it to curve. So I'm going to curve it a little in, and a little out, and then maybe a little in again, and connect. And then this checkbox ends the spline. If you are editing a spline, it looks complicated, but what is actually happening is that these green handles just let you change how much it's curving. And finally, I'm going to put just a straight line down the center of this to close in this sketch.
So it automatically closes?
It won't automatically close. Sorry. There were only 3 lines here before I put in that 4th line, right? This one, and this one. Once as you close it, so that 4th line, it turns blue. And that is an important concept. The fact that it is blue means that Fusion considers it closed. You have to use a closed shape with 3D transformations. And that's why we needed that last line. Does that make sense to everybody? Cool. So that's all we need for our vase. This is probably not a good vase now that I'm looking at it, but yeah. So I'll hit Finish Sketch. And again, if we click the home on our view, you'll see that it's still just a plane. But that's OK. Now we can go to Create, and then Revolve. So we're going to select that thing that we did. And now the axis. You have to tell Fusion which direction do I want to spin this. And you have some options, right? I could spin it around this edge, but I could also spin it around this edge. That could be interesting. But let's do it the way that it was intended, right? And so now you get a shape. Yeah.
Wow, and you still see the sketch that is just that little chunk.
And you can see you also have some options here. If you don't want to do it 360 degrees, you don't have to. You can make half of a shape or a quarter of a shape. And this gets powerful if you're thinking about, maybe I want to make something that is a combination of this and another shape. Perhaps I would make, a square extrusion over here, and then add this on, and then add a big sphere over here. And again, this is parametric, right? Like if I look at this and I'm like, it does look like a stupid bell. I can go back to my sketch. Oops. I can go back to my sketch, and I can change this spline to maybe make it look more interesting. Right? Maybe I don't even want it to be 40. I want it to be 20. And I can pull this in and
now
do some crazy things. Finish sketch.
If you did, instead of having a perfectly vertical line at your axis, you could then, you could almost make a vessel that way, right? If
Yeah, exactly. Yeah, so if you wanted, you could now, you could define that inner shape, right? So let's just pull this over just as an example. That now I need to actually do this revolve 360 so you can see it, but yeah. Not 480. So I click too many wrong buttons on my keyboard.
It won't let you do something crazy like 480, right?
Oh, I don't know how that got tilted,
Nice.
but that's interesting anyway. Oh, I know what happened. It's because when I defined the axis of this revolve, I defined it on this edge, right? So now it's actually revolving around this edge. I didn't revolve around the y.
So the axis isn't,
It can be the y, so let's select the y so it does what I was intending it to do in the first
And
place.
now
Now it has a hole.
Okay. So that's your two functions when you hit your.
Yeah, when you do the revolve, it's gonna ask you what profile do you want to revolve. That's your two-dimensional shape, and then what axis do you want to revolve it around. And it will the axis is any straight edge. So it could be an edge of your drawing. It could be one of the origin axes. It could be the straight edge of another body in your drawing already. That could be interesting for circumstances.
Yeah, this is cool.
And again, we can keep going with this, right? And say, I want to make a sketch here on the top of this, right? And I'm gonna take a rectangle and just, I'm going quickly just to show you some possibilities. I'll make a rectangle here, finish sketch, extrude this down so that it cuts, right? So now I have a cutout in here. So now we're getting more interesting. And then let's, as a sneak preview for something that we can do in the intermediate class, what I can do now is if I select all of this, so this is in three-dimensional space. I can select these, this kind of feature, go to create. There's pattern tools not only in two-dimensional space, but also in three-dimensional space. So now I can say, I want to take this thing around this axis, and I want it to happen 5 times. So now I have a much more interesting cylinder.
So cool.
And so we'll talk about that more.
And it's just wide open.
Yeah, because now the next thing is you take this, export it into Blender, and start mashing around how these points are actually interacting, and you can get something quite organic. But that is a sneak or a taste of parametric modeling. So like I said, take this home, start making your own shapes.
So we should think of keep it under 4 inch by 4 inch?
Yeah, try to keep it smaller just so that you have a chance to either print multiples or more people can print more things.
Sure.
We can print more than one thing on the bed at a time if it's small too. That's another option.
So
again, the small machine, 100 by 100.
Yeah.
The big machine,
Oh, I see.
180
So
by
the bed-
180.
Okay, so you have 100 by 100, and you could have multiple going at the
Mhm.
same
Yeah. So
Cool.
yeah, hopefully it wasn't too overwhelming. But yeah, like I said, next week we will talk about using the slicer. So how do we make decisions about how we want it to form this model? And then also how to actually operate the machine. So how to mix the clay to the right consistency, how to load it into the machine, what you need to do to clean it, that kind of stuff.